Yeah, Krishna, I'm audible. Hello, Krishna, can you hear me?
So your voice is low.
Is it fine now?
Yes, sir.
Okay. Alright, so basically today I'll be starting with the topic magnetic field due to current carrying loop. Okay. So we are going to discuss about what will be magnetic field due to a loop. Okay. Loop. Which kind of loop we are going to take? A circular loop. So three to four phases are there. First we'll be calculating at the center. So assume this is a current carrying loop. Assume current I is going on and center. Assuming the radius to be r. Okay. So Kirtana, if you could remember, in the previous topic, when I was talking about n polygon thing, I have already given you the derivation for this one, right? That is a different way of giving you derivation. Okay. Could you remember the formula of magnetic field at the center of a circular loop using the previous method where we started with this, and said, okay, if I take this n is
You not I by 2.
right, mu naught I by 2r, right? This is the formula. Okay. Now we are going to derive the same thing by using another method. If you see carefully, can I say that each of the component having a charge? So if I say that this is a small portion, right? What is the uh, magnetic field due to this small portion? You will say dB is equals to mu naught by 4 pi. Okay. Assuming, mm, okay, yeah, this is 4 pi. Current is I. Okay. What is the length I'm going to take? The very small portion I'm taking, right? This you can call this the DL into what is the rest part? The distance is R divided by R cube. Okay. If you see what is going to be the direction of magnetic field. So this is my current going. Okay. The vector current vector is here. Basically distance vector. This is my R vector. So when you do I this dl cross R, what is the direction you are supposed to get? Kirtana, what will be the direction of the magnetic field at this point?
Outward.
Think again. Okay, how do you calculate magnetic field, Kirtana? How do you calculate? What is the way? How do you
The
compute the
4
direction of
fingers
magnetic
to
field?
the R, sir.
Forefinger to be at which
To
side?
the R side.
R side. Why to keep R side? Look. I'll give you a very simple way. Okay, what is that simple way? Take your hand. Okay, and this is your thumb. Basically, this is your thumb. And these are the four fingers. Which hand it is supposed to be? Right hand. This thumb should be pointing towards this current. So if you see this figure, I will rotate the whole. this kind of thing. Okay. Now you can see this direction is pointed out by this thumb. These are the four fingers which is pointing towards the radius distance vector. Okay. Wherever your palm, okay, front part of your palm is pointing, okay, that is the direction of current. In another word, assume this is the 3D plane I'm trying to build up. So this is upside, this is this side. So your palm is facing this side, okay? So this is your magnetic field. Clear? So upside you are pointing, so this is the direction of magnetic field. So similarly in this case, this is this thumb pointing, fingers pointing this side. So palm is pointing inside this plane. Okay, so be careful with the values. Okay, so this is inside. Acha, I'll just ask some points, okay? I have a charge which is moving with a velocity v. So, and if I wanted to calculate magnetic field here, what is the direction? Very simple. Point thumb over here, four fingers this side. Wherever your palm shows, that is the direction of magnetic field, okay? That is the thing. So two things we have got it, and on the basis of this we can decide. Now this is fine, but if you see this DL and R is perpendicular to each other. So what I'm going to do is I'll say, okay, leave it, remove this thing from here. You can rewrite this thing as dl by r cube itself. This is magnetic field. Understood this part? Now, if I integrate this thing, from where to where I'm going to get from zero value to v value, and this part is going to get integrated from zero to complete length. Okay, understood? Because I am taking a small part. When you add all small parts, what is the total length you are going to get? The complete parameter. And what is the parameter? 2 pi of r. So you can say this b is equals to mu naught I divided by 4 pi I, this 2 pi r divided by r, cancel this 2. So what you are left with, it was false. Once you have cancelled out mu naught I divided by 2r. Is it clear?
Yes.
Understood, Kirtana? Okay, if you see carefully, this was a complete circle. That's why I got this. What if instead of complete circle, I am having only some small kind of circle, maybe only this? Then in that case, you can say, because if you see carefully, due to this part, I got the magnetic field dB as this thing itself, right? So mu naught I 4 pi divided by 4 pi I dl divided by r square. It is r square. Now I had to integrate it 0 to b. And where this will go from this 0 to what is the total length? If I take this, this, if the angle is theta, if the radius is r, what is the arc length? Arc length is nothing but theta by 360 into 2 pi r. Okay. And in this case, because we are into radian, so we can actually remove it. And we say that 2 pi cancel. So theta times of r is your arc length. So actually you have to remove the whole thing. And now you can say you are going from 0 to theta times of r. Okay. So b comes out as mu naught I divided by 4 pi I times of, okay, I is already, sorry, theta times of r divided by r square. So it comes out as mu naught I uh, divided by 4 pi r times of theta. Okay, this is the final number. So if your theta is 2 pi, you can simply put the value and get the answer. I hope it's clear for you.
Yes, sir.
It's clear, right? Okay. I'll move to the next page. Okay, one more thing, Kirtana, you can add it up that currently what I was saying is in the previous problem part itself, in the previous case, I had the only one turn, okay? What if it is something like this? One turn, another turn, another closely packed. If they're very closely packed, you can say each loop if you see the first part, it is a loop having a current and magnetic field. Another loop which is followed in the same current and the magnetic field here. So you can say if n loops are there, whatever the magnetic field you are getting, you just multiply that with nb. So the answer will be nb. Okay. B is the value
Yes.
of each loop, and if you have n number of loops, you can see it is for the n times of the total loop here. Okay. Mm, yes. Okay, if you see carefully, this contains two formulas, right? The one formula is about, where is it? Yes, I think I didn't draw it. Basically, when you derive it, the complete length, okay? This theta r when you were writing, it was a complete length, okay? Even better, make it as mu naught I divided by, here actually two i's are there, it should be only one, 4 pi L divided by r square. This, what is the L? L is the complete length, okay? Complete length basically, complete parameter, okay? The whole of the length is parameter. All right, so let's move to the next page. Okay, so let's calculate. Hmm, Assume we are given a circle if your current is going this way, okay, Kirtana, look, now I'm giving you one problem. It's kind of merged problem, okay, from the topics you have done so far. So assume you are given a circle and there's a wire connecting from here to here. Assume that current is going in this way. This is I current in this coil, and here also it is I current. This is center point. There's a center point over here. This is center point. At this center point, you need to calculate magnetic field. Okay, this is point B. Calculate magnetic field at point B. Uh, the okay, you need some angle also, so you can actually keep it. This radius is r, this radius is also r, and this is given as theta. Okay, now you can go and try to solve it. So Kirna, take your time, solve this problem. Time I can give at max maybe 20 minutes. No, not 20, this is too much. 5 minutes, okay? This given theta is equals to 120 degree. Radius, okay, let it be a variable. So you can now solve it, okay, or get me the answer, okay? So start solving. One more thing. This is not a part of circle, okay? The current is not here. The main circle is like this. Main geometry is like this. This is a straight path, then something like this kind of geometry is there. The current is flowing in this way. I just shown you to make it extra, but it is not there. You can see I have divided this. This part is not. They're gonna solve it and get me the solution first. Okay? If you solve, just let me know the solution and answer. If you don't know how to solve it, please let me know. I will explain. मैंने उसको बताया, but I
Sir, is it U not I root 3 by 4 pi r?
How much you have got?
U not I root 3 by 4 pi r.
Not exactly. You're missing something. It will be having two addition based part. Okay? It won't be a complete just a single entity. It will be having two entities which are getting added. Okay? But you won't be able to add completely. So you'll be writing in the form of a plus b something or a minus b, whatever it is. Okay. Okay. Just tell me, how did you approach this problem? What was your first approach? Explain me your approach in this problem. What did you see in this picture? What do you think?
I calculated the length of the path where the current is going, like the chord.
Okay, which part the current is going?
The chords.
The chords. Wait, is it really only on the chords? What about the current part? Current is everywhere, right? It's a complete circle. It's a complete loop. But it's not a complete circle. One side I have this, I have this bent it. Okay? It was a complete circle. I just pushed it, or you can say I had a circle. I took this circle, and then I added a direct wire from here to here, and then I started current. Now I'm saying give me the value of current. Give me the value finally. This is what I did. Can you can you think of it? What should be your approach? The main thing is approach, and the problem solving approach. Answer is different thing. That is the calculation based part. If you are good at approaching the
Like
problem, then
from
it's
the total circumference, we need to subtract the segmental length and add the chord length.
okay. So can you try it once again if you have got this kind of
Yes.
approach? Alright, do it once again. Okay?
Sir, is it U not I by 4 pi into 4 pi R by 3 plus R root?
Wait. One by one, just tell me values.
U not I by 4 pi into
Okay.
4 pi R by 3 plus R
It's
root 3.
plus. Okay, you have so you have taken the things into common, right? Okay, I'll write this. I'll write the answer. Just let me know if you have got the same thing. One by three here. Okay, one more thing. First of all, it is what I can say. This is- Kirtana, have you got the similar solution or something else is your answer? Oh, Kirtana, are you there?
I got different answer.
Okay. Uh, all right. So look, I'll explain once. Okay, from starting. If you have got the similar things, so let me know. If you have made mistake, where you made mistake, just let me know that. Okay. So look, kids now. Basically, this is a complete map, right? If you see, this is acting as a circle, this part, and this part is acting as a straight line, and this is one. So can I say that I'll first calculate magnetic field due to this straight line on this point, okay, and I'm going to calculate magnetic field due to this circular part on this one. So you can do one thing, calculate it one by one. We directly know the formula for this curve part, so I will do it for the first curve part. Okay. So what is the net magnetic field at the center? That is a merge of two things. It is basically B due to straight line due to line L plus P due to C curve. Okay. Now what is B C curve? If you see due to curve, what is the magnetic field? We have just studied a formula. You not I divided by um, yes 4 5. I mean R when cancelled out, R will be there. Theta times of if you could remember this formula. It's on the theta. This is the formula, right? So here in this particular case, out of the total angle is this. Here you are given theta is 120 degree. Okay? So you can say 360 minus 120. What you are left with 240. So this part is basically 240. This part is 240. Okay. So this becomes 2 by 3 times of 2 pi. Understood this thing?
Yes.
So you can directly go and substitute the value. If you do this, what you are looking at 2 into 2 pi divided by 3. Cancel, cancel, cancel. Cancel. Do not I by 3r is the answer. Okay, from this part. And if I ask you what is the direction, you will say, sir, this is outside because line is this way. If you put your thumb in this way, fingers will be pointing this way, your palm will be pointing upside towards me. You have to use right hand for this. Okay? So in this way, you are getting this as an answer. This is a point. This point is basically defining your direction. Okay, I'm saying upside. What are BL? Uh, BL is basically this kind of thing. This is a length. This is a point. Okay, this is the radius R. This is the radius R because isosceles triangle. So whatever the angle is there, but that if I divide it, it is symmetrical divided. Total is 120. This is 60. This is 60. And you know the formula, right? What is the formula due to this one? Magnetic field is I divided by 4 pi. Current as it is divided by distance. Okay, what is the distance? I don't know. I'll calculate it once. Okay, sine of theta plus sine of theta 2. Here both are same, so you can directly put mu naught I divided by 4 pi I times of distance divided. This thing is there. So what is the value of A? If you see carefully, this is R, this is A. Okay. So this becomes R times of cos 60 because you can see if you could take the horizontal component, vertical component. So this distance is nothing but uh, horizontal component of this radius r. So this becomes r cos theta. So r cos theta is cos 60 from the r by 2. Keep r by 2 over here, and here you are going to do 2 times sine of 60 degree. Okay. So what is the answer you are going to mu naught I divided by r only. You cannot use it r only. Something is here. 2 into root 3 by 2. Okay. From here to here, if you cancel it, it becomes 2 by r. And this side of the, what is the answer here? Mu naught I root 3 by 5. So now you just have to add it as okay. What is the direction? Due to this part, current is going this way, current is going this way, current is going this way. So if you keep thumb over here, fingers pointing here, upside down. Pointing here, fingers pointing here, upside down. So that is the reason. That will be there. So yes, so you, what is the VNet you have got? Something around mu naught I divided by 3R plus mu naught I R root 3 by 5. Better if you write it in a different way. Mu naught I by R 1 by 3 plus 1 by 3 to the reason and root 3 by 5 to the reason. This is the formula I've got. Basically the whole derivation of the final answer. If you have any query, please let me know. If no, let me know which part you did as a mistake due to which you are getting the wrong answer. What is the main part due to which you are getting the wrong answer?
I calculated the PC room.
What you calculated? Yeah, please now what you calculated? PC incorrect, right? Another follow-up problem I can give you is that instead now the situation is something like this. You have this curved portion, the removed part of it. Now what I'm doing is my current is going in this way and my current is going this way. Okay, this is I current and this is also I. This is a point 120 degree radius is R. You have to calculate magnetic field of this one. This is a problem you can take and try it as a homework. Do you want to try for this problem now or do you want to take it as a homework? It's your call.
I will try it.
You try it. So I will leave it as a homework part for you. Okay? I will get next. The problem. So here's another problem now is something different. Okay? The difference is this is one loop, okay? And this loop contains inside a bigger loop. These both loops are connected in a sense that this is connected out and this is also connected out. So current is going from here, here, here. This is the current going. This is center point. We have to calculate magnetic field in this point. The distance, the radius, this radius is, you can call this in R1. This distance you can call it as in R2. Okay. This basically this I want to display the values which current is given as I, radius is given to you. You need to calculate magnetic field at the center point. So the problem, try to solve it once. Solve it once and get me the solution first. I have to give the solution. Please take care of this, what kind of figure you are given. Okay? What are the formulas for each figures? And what's the direction? Good three things you need to remember and keep track of when you are solving any problem in this chapter. Okay, direction is very important.
Yes. Sir, is it unit I by 4 into 1 by r plus 1 by r?
How much you have got?
Unit I by 4 into 1 by r1 plus 1 by r.
Two. Yeah. Can you repeat the answer once? Kirtana, can you repeat the answer once?
Unit I by 4 into 1 by r1 plus 1 by r.
Actually, the answer should be something like this. P is equals to mu naught by 8. Yeah, I think current is as it is. R, who's the greater one here? R1, oh, sorry, it should be 1 by R1 minus 1 by R2. This should be the answer, ideally. You know why this kind of solution is getting? I'll explain it once. Look, okay, have you considered this part also in this magnetic field? Kirtana, have you considered this part also? The like magnetic field to these two smaller parts?
No, sir.
You don't even need to know because line wire is this way, point is this way, and you know if if you see carefully, the angle is basically 0 0 degrees. So if you use that formula, sine of 0 plus sine of 0, and the rest part is there, so this thing will return you 0. Okay, there's no magnetic field due to these two parts. What are the main parts which are providing you the magnetic field? You can say inner circle, outer circle. Okay, so I'm going to call them as B net as B inner circle plus B outer circle. Okay, if you see about the inner circle, current is this way. If you use that rule, finger rule, thumb, all the fingers this side, current is going this side. Palm is facing upside, meaning to say at this point, due to this inner loop, my current is going this way. Due to this side, my fingers are facing this side. Palm is facing inside it. So due to this one, I am getting this. So you can say that direction of both current is opposite. Okay. So what I'm going to say is, let's say this is x, this is y coordinate. Okay, and so this is inside. You have a z coordinate. You can say something like this. So you can say this bi is nothing but what is the magnitude of internal one? Because it's a mu naught by 4 pi. Current as it is, distance is r1. Okay, and theta multiplied by theta. And what is the direction? It is going inside, right? Due to outer one, what is the value of current? That is inside. It is going inside. Due to the inner circle, the magnetic field is inside. So you can call this as z, which is k direction. Plus mu naught I divided by 4 pi r2 theta. What is the direction? Outside. So minus of k. Okay. So you can see that now it's better to take now put the value of theta. If you see what is the theta over here, complete theta, right? It is going from 0 degree to complete theta. Actually, sorry, the previous answer which I wrote instead of 8, it should be 4 only. Okay. So if you see, just put the pi over here because angle is pi divided by 4. Pi to pi get cancelled out. You are left with r1 or k as it is minus something like u naught by I da, 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 4 r2 this k. Okay, from where this negative came, I took this negative outside. So this thing you are left with. You don't just make cancel out because the radius is not the same. Mu naught I divided by 4 common 1 by r1 minus 1 by r2. This results to something around k. Okay, that's the solution for this. That's the solution for this problem. Okay, if you are clear with the solution, just let me know. Or else if you have doubt, again let me know.
Clear.
It's clear, right? Okay, so that's all for the today's session, Kitna. We'll get you with a new topic maybe or have some problem practice. Uh, okay, I'm giving you two figures. You have to solve them as a problem practice part, as a homework part. So the first figure is the same which I gave you earlier. First problem is, but I won't write the whole definition, so just remember the problem carefully. I'm basically this is a part of a circle, but it's not a complete circle. Okay? Assume you had earlier a circle. You had um, this is a circle. What I did out of this circle, I took half part, basically only this part. On this part of circle, you are having a line, something like this. Okay. Now I can actually remove it. Just keep it so that you don't have to be confused. This is the center of the circle. This is the distance from here. Uh, current I is flowing in this loop, in this smaller loop, okay? So you have to calculate magnetic field at this point. And angle you want it as 120 degree again. Second problem is when you are given a complete circle like this, so basically you have this kind of circle. This was the circle. This circle is actually connected with a square, something like this. This is the center of your square. Okay? So what I can say is, just a second, I'll make this figure perfect. Now, in this figure, if you see carefully, what you're given is, um, I will square 120. Yeah. So this is your outer circle, okay, basically, and this is your third part. Here your current is flowing in this sense. Current is going this way. From here it is going directly this way, this way, this way, coming back to this one. This is a complete loop. This is a complete loop. Okay. Here the radius you can assume is to be r, and here the distance you can assume to be a. This basically side of this square is about a. You can call this as, no. Let's call this as r, two times of r itself. This is the thing. We have to calculate magnetic field at this point. This is another problem. So I hope you understood the problem. Krishna, is it clear?
Yes, sir.
Yeah. So yes, we have to solve these two problems. Okay? That's all for this session. I will end the session right now. Okay. Goodbye. We'll get these PPTs. Try to solve these problems. Otherwise, okay. Goodbye.